Hi everyone, welcome back to the new video. In this video, we're going to talk about collision handling and hashing. In the last video, we've talked about what is a hash table and what is a hash function. And in this video, we're going to talk about collision handling. Like last time we visited, we saw how in a hash table we were facing a collision. So in this video, we're going to discuss about that. So let's have a look at what we were discussing last time. In the previous lecture, we have seen that there were two objects that were colliding at the same place. Let's say at a position 5, we have Margareta 199 and Farmhouse 250. So to avoid such a situation or to how to resolve such collision, we are going to discuss in this particular chapter. Why basically collision happens? So we will be basically discussing about two things. Firstly, we'll talk about how we can minimize these collisions. Secondly, even if after minimization, we have certain collisions. So what are the methods or strategies to handle these collisions, right? So first of all, as you people are already aware, let's say there's a function fx that takes inside it chocolava, and we get a particular value, which after, let's say, taking mod by table size, we get a value that is, let's say, x. And there's a second function, this is like the same hash function. After we pass on, let's say, Farmhouse through it, we are getting the same number. So this is a state of collision in which both chocolava and Farmhouse are coming at the same place in that particular hash table. So we are looking forward to minimize these collisions. We are looking forward to a method so that these collisions don't happen. So how can this be possible? Let's see. So how can these collisions be avoided? There's a first thing that is known as a good hash function. So how can we build our hash function in such a way that we have minimum collisions? Secondly, we'll see collision handling strategies that includes separate chaining. In this video, we're going to particularly discuss about separate chaining and how this is helpful in resolving such collisions, how this is helpful in dealing with such collisions. So now let's talk about how we can design a good hash function. So the first thing is reducing collisions. So to reduce these collisions, we can follow a strategy in which we are able to uniformly distribute our data across the hash table. So to uniformly distribute, what I mean to say by this is, let's say this is our hash table and these are, like, let's say the size of the hash table is 10, table size is 10. So if the table size is 10, so we are looking forward to such a strategy so that our data is uniformly distributed across all these pointers rather than just on a single pointer. So the probability of each bucket getting selected is uniform. That is something that we need. So how can we do that? So let's try to discuss with what a good hash function should look like. Let's take an example of a very simple hash function in which we are just taking a mod of that particular number with the table size, and let's see what comes. Let's take some example and see how this goes into a hash table with the table size of 10. So let's say we have these numbers 15, 25, 35, 49, 105, 29, and so on. Let's say we have these particular numbers and we are trying to add these numbers into our table size passing through this particular hash function. The hash function is number mod table size. This is the hash function that we have currently, and number mod table size is, let's say, 15. When we do a mod of 15 by 10, and that is the table size, we get 5. So 15 maps to this, we have 15 here. When 25 is there, 25 mod 10, it will again be equal to 5. It will be at the 5th position. We have 25 also here, again 35 also. 35 mod 10 will be equal to 5. We have 35 also here. 49 mod 10, we have 9 at this location. We have 49 here. 105 again we have at this particular location, and 29 again we have at this particular location. So this is a kind of a hash table in which all the entries are coming out to be at the same point. Like there are 4 numbers that are colliding at one point and 2 numbers colliding at another point. So it's a very, very bad, I would say, uniformity. what else should be the case, like how can we avoid this particular situation? We need to make a hash function such that the table size that we have chosen, it should not be a very common composite number, rather than it should be a prime number, so as to avoid such kind of situation. Like let's say we have this kind of situation in which we have a prime number, let's say 13, instead of 10 we have 13 as the table size. So if we have 13 as the table size, so what would be 15 mod 13? So it would be 2. 25 mod 13, it will be 12. 35 mod 13, it would be 9. Let's say 29 mod 13, it would be 3. And 49 mod 13 is equal to 10. So now we see that all these numbers are pointing to different locations in this particular hash table, and we have avoided a lot of collisions that would have happened, right? So this is one particular method on how we can reduce these number of collisions. Secondly, now let's discuss how a hash function for a string look like, and how we can make a better and a good hash function for strings in general. Now let's say to discuss hash functions in case of strings, let's take a very common example, very simple hash function, I would say, to add the character sky values of the particular string. Let's say we are taking the string named as choco, just for example, like we were discussing about choco lava. So let's say we are taking the string choco, and inside the string we are adding the sky values. So the addition of these sky values comes out to be 524 mod table size. Let's say if it is 10, so we have 4 as the output. So choco will be placed at 4th location of the hash table. Let's say this is the hash table in which we have 4th location, so choco will be placed here. So it is a one kind of hash function for strings, but what all potential problems we can face in such a situation? So the first problem that we can face with hash function for strings is, problems that we can have with this particular kind of a hash function for strings is, let's say, anagrams. You all might have studied what are anagrams. These are, let's say we take an example of cat and act. So both cat and act have same letters, same alphabets in them, and the potential sky values for cat and act would come out to be same. So again, there's a chance that they both will collide. So this is something that we should look upon to. And there is a second thing, that is non-uniform distribution. Let's say we have all the 3-letter words. Let's say we have cat, we have sad, we have bat, we have rat. So all these words would be very limited, like it would not be a very good distribution. Let's say we have a hash table with the table size of, let's say, 500, but all the 3-letter words, when their sky values are added and its mod is done with the table size, then they will occupy a very small space, let's say a very small region, and they'll not be distributed uniformly across the entire length of hash table. So we'll have multiple collisions here, and it would again prove out to be a bad hash function. So how can we resolve this particular kind of a situation? Okay, and we add the sky values in such a way that, for example, for the word choco, we have this kind of a structure. Let's say we take the value of k equals to 37. 37 is a prime number and it's very big. So c into 37 raised to power 0, h into 37 raised to power 1, o into 37 raised to power 2, c into 37 raised to power 3, and o into 37 raised to power 4. If such a situation arises, so after doing this and taking the mod with table size, so after doing this, both our problems are going to be resolved. So the first problem that we had was of anagrams. So anagrams in this case, if you are adding the sky values and making the hash function in such a way, so anagrams will have different locations or different address values will come. Let's say for cat and act. So in this case, cat will be c into 37 raised to power 0 plus a into 37 raised to power 1 plus t into 37 raised to power 2. And in this case, it would be c into a into 37 raised to power 0 plus c into 37 raised to power 1 plus t into 37 raised to power 2. So both these values, when taken on mod with the table size, are going to give us different values, and hence our problem of anagrams is resolved by such a hash function. Apart from that, the problem of uniformity is also resolved. Let's say earlier what we were having, like let's say there are three numbers, cat, sad and bat. So if we are performing it in such a way, then our entire length of hash table is going to be covered. Like we'll have a uniform distribution of these particular addresses, and we'll resolve the second problem also. But still, if there is a problem in which two objects are colliding at one place, let's say cat is here, bat is here. So what kind of technique we are going to use here? This technique that we are going to study is known as technique of separate chaining. Let's discuss a little about separate chaining technique. So what is the technique of separate chaining? Technique of separate chaining can be implemented using a linked list. Let's say we have this particular table, hash table, and we have this given set of data. We'll understand it with the help of this particular example, how separate chaining exactly works. So let's say we have these particular numbers, and the hash function that we have currently is again number mod table size. Table size again we are taking in our case as 10. So when I do a mod of 5 mod 10, it will be placed here. So I'll be getting 5 here. Next 15 mod 10, I'll be getting 15 here. 27 mod 10, I'll be getting 27 here. 31 mod 10, I'll be getting 31 here. 32 mod 10, I'll be getting 32 here. 55 mod 10 will be here. 64 mod 10 will be getting 64 here. 91 mod 10, 91 here. 98 mod 10 will get here. 74 mod 10 will get 74. So what happens actually is we are forming a linked list or a list at this particular structure, and whenever we require this particular data or this particular entry, we'll traverse over this linked list, right? So let's take an example. We need to find out 55. So we do 55 mod 10. After doing 55 mod 10, we get 5. We go to the fifth location and we check upon this particular linked list, and we traverse over this linked list to get the particular entry of 55. So this is basically the technique of separate chaining. But again, in separate chaining, how we are going to do the things, there are certain limitations. We should make sure that first thing, the length of the linked list is minimum. We should not have very long linked lists at a particular hash table address, because that will again involve a lot of complexity traversing over those linked lists. So what can be done in this case is there is something known as a load factor. So load factor is like we need to take care that the size of the linked list is small, and we can have this particular load factor, like it's basically a threshold value. Once our value exceeds this threshold value, then we can increase the size of our hash table to twice the size. Like currently, if the size of our hash table is 10, let's say we'll make it 20 if our load factor is increased. So this load factor can be decided upon various factors. We'll discuss about it when we discuss rehashing. So rehashing is another concept. So I believe this was all for this particular video, and we have got to understand like the aim that we are having in hashing is to get O of 1 average case time complexity. So that is probably what we are aiming at. So we'll discuss about this more in the next videos, where we'll try to code a little bit more and we'll try to understand how hashing exactly works. I hope this video was clear to the point of understanding based upon these collision handling techniques. We'll discuss about some more collision handling techniques like linear probing, quadratic probing in another video. So this was all for this video. Thank you so much. Don't forget to check out other videos on this channel and press the like button, subscribe button, and share it with the friends for more such awesome tutorials ahead.